to use the plugin. So you go to Plugins, NanoDefine, and first you go to the Settings Manager. So all of the information concerning these different settings can be found in the documents I mentioned before, and more particularly in this document. You don't need to understand everything in a lot of details to make this work, but what you do need to really keep in mind are a few things. First, according to the type of images you have, or how the particles look and how they are organized one next to another, if they're like overlapping, or if they're touching, or if they're not overlapping, you'll want to use different modes here. So ellipse fitting mode is great when you have spherical particles, but it really only works for spherical or ellipsoidal particles. As soon as you have something that has a little bit of an irregular shape, you want to use Watershed. And if by chance you happen to have irregularly shaped structures that are separated from each other, then you can use single particle mode, or else you can't really do that. So in the case of our image, I won't show you ellipse fitting mode because there's not much to it. All you have to play on if you're working with ellipse fitting mode is the object to background intensity difference here. So you can lower it when there's a really good contrast, and if the contrast is not so good, not so high, then you really have to increase this difference so you don't see the noise as much. Then all of this, I haven't actually seemed to need it. However, you do need to use inverted images in the case where you have black particles on a less dark background, and you do want the software to ask you to select a region to analyze so as to select a zone that does not contain the scale bar. And here you have to put in the directory to your R program, and this directory needs to include the file that has bin in it, the file that is called bin. So that's important to know. So let's try using the ellipse fitting mode on this particle, on this image. Sorry, let's try using the Watershed for Irregular Structures mode, which is more adapted to this image than ellipse, because these are not ellipsoidal, but rather very asymmetrical. So, as well as playing with the object to background intensity difference, when you're in Watershed mode, you also want to play with irregular watershed convexity threshold. So basically, the higher this number, it goes from 0 to 1, the higher this number, the more it will cut out your particles into separate types of particles, which may create some noise and may create some fake distorted particles. So we'll see that. We'll start with the default threshold and also a default intensity difference here. And let's go. Plug in NanoDefine particle sizer. So if I had selected different images, this selection would cover all of the particles, all of the images. And here, just to go a bit quicker for this video, I'm just using one image. Okay, so here you can see the results in the shape of a table, as well as a histogram, which will be coming. Here we go. So, these are the number of particles it has found. You can also see this number 68 in your table. And then you, in my experience, you have to do some visual interpretation of how correct these results are. So you can see that some noise has been selected and some really small particles. So I know that this is not what I'm looking for. And then when you look into here, you can ask yourself, okay, has it selected the particles correctly? So you can click on the image to take the selections off. Right click and restore particle selection to compare. Here you can see that it didn't really cut out enough. Same thing here. You can zoom out. I'm doing control scroll with your mouse and zoom back into a different area. Also assess how well these two parameters are adapted to our image. So here it's likely that we'll never be able to really separate this particle from this particle. Even to our eye, we're not sure that they're really separate. But this is for sure something separate, and here too. We can tell, and the plugin should be able to tell too. But when we look at the particle selection, we see that there's some stuff missing here. So we want to increase the convexity threshold of the watershed mode to have two separate particles here. We can just abandon the idea of having particles here. So let's change our parameters. Close everything. You can also take off the overlay. There you go. So we'll increase the convexity threshold, and we can also try and decrease the intensity difference, because there's rather good difference between rather good contrast in the image. So let's try these parameters, and we'll keep the whole region we see here, so no need to select anything, and you can go OK. So now, as we decrease the OTB, intensity threshold, and increase the watershed convexity threshold, we see that we have many more particles that have been detected, so that's logical. We have 97 particles instead of 68. And when we look at our images, we see that, yeah, we have been able to separate these two particles, so that's nice. Here too. Not this one, but these two have been separated, so that's nice. However, we see a lot of noise, so there's two ways to get rid of the noise, the particles that are not supposed to be analyzed. The first is to sort your particles by size according to